If I can have everybody's attention, please. Okay. Oh, Kirsten can talk to Isabella. Other than that, no talking. Now, the question was brought up over last night's homework about what is the point behind number 5. I'm not actually going to do number 5 here, but I will show you how to do a similar question so that you can know how to get it right. It is not in any way, shape, or form a difficult question. We have gone over the Pythagorean theorem before. So this says use these 2 points. I'm going to use a different 2 points. And here's my line. So the question now is, how do you find the length of that line segment? The way you find the length of the line segment is you create a right triangle. This is 2. 1, 2. 1, 2, 3, 4. This is 4. And I get 2 squared plus 4 squared equals x squared. Okay? Does that make sense, everybody?
Yeah.
And then you rock it through.
I thought we were just learning putting a line.
No, that's how you find the length of it. So in other words, see the right triangle. Once you see the right triangle that can be created, it's an easy question. Okay? All right. Now, let's get going on today's lesson. You guys already took the quiz, and here's the deal. If you did not do well on the quiz, you need to be an extra help, and you really need to get it straightened out, okay? Most of the class got 100, which means I'm not going to slow down. So we'll go over each day in the do it multi-step equation, so you can use that to catch up and you can come to extra help. But I'm certainly not going to spend a whole lot of time going over this stuff. All right, so we take a look at the first one. This is a basic 2-step equation. Very, very simple. Add 6 to both sides. The only way to really go wrong here is to mess up your negative signs. 5x is negative 10. Divide by 5. X is negative 2. Okay? All right, the next do it question. Now we get into a danger moment, okay? What kind of 2 is this right here? Folks, what kind of 2 is that? Positive. What kind of 2n is that? Negative. So the 2 is positive, so I have to do minus 2. 12 minus 2 is 10 equals. Now here's the next danger moment. So many people just put 2n, but it's not 2n, it's negative 2n. So I need to divide by negative 2, and I get that negative 5 is equal to n. Okay? Questions on that? Yes?
My sheet says 12 equals positive 4 minus 2.
Today's lesson 24?
Yeah. I'm looking at 23, that's why.
Okay, that explains it. All right. All right, next. Distribute the 5 to all sides. 10n plus 5 equals negative 35, and now it's a standard 2-stepper, so we just go with it as we normally would. 10n equals, if I have 35 negatives and another 5 negatives, what do I have altogether?
Negative 40.
Negative 40, nice. Divide by 10, n equals negative 4.
Yeah.
All right, so now we get to letter D, and when I look at letter D, I have to, now we're not in a basic 2-step mode like this. This was distribute. Letter D, I got to ask myself, is this a same side situation or is it an opposite side situation? What do you think, guys? Opposite side. Opposite side?
Operation.
Opposite operation. Very good. Jaden, how'd tennis go yesterday? I didn't realize you were playing tennis. I saw you get off the bus.
Oh, yeah.
4n plus 7 equals what?
Negative.
-1. Yeah, what's the trap there?
Done.
Kids forget about that negative sign. They do it all the time. You got to be in the habit of peeking. Sam's sister Kat is the catcher on the softball team. And there's a situation in baseball and in softball. We call it first and third, hope she goes. There's a runner on first, there's a runner on third. Here's second base over here. Here's home plate. Here's the pitcher, which is Emily. Here's Kat, which is catching. So Emily pitches the ball, and this runner goes to steal second. Now, if you throw, what could the runner on third do? Run home. So we have like 4 trick plays or 4 plays based on the circumstances to which one we want to do. But whichever of those 4 plays Kat does, as she comes up to throw, she's supposed to peek at the runner at third. And if the runner at third leaves too early and starts running home, you stop whatever you're doing, you turn, and you get that girl out. Now, when you solve an equation like this, every time you have to constantly be peeking for negatives. And then in the back of your mind, you're hearing Steve Irwin go, danger, danger, danger. You always peek for those negatives so that you don't lose track of them. -7, -7. 4n is -8. Divide by 4. N is -2. And then over here, this is a little bit of a tricky one to distribute. What kind of 2 is this? Negative. So I'm going to distribute both the 2 and the negative part of this. And the negative is going to change every sign in the problem. So I get 4x minus 2x. And then the -2 multiplied by this -2, I have to change the sign, plus 4 equals 14. Okay? And then same side, same operation. 4x is minus 2x is 2x. Plus 4 is 14, minus 4. 2x is 10, dividing by 2.
Wait,
X is 5.
wait.
Yes.
Can I borrow your
How do
eraser?
you make it
Well, I would prefer to think of this as a positive sign, because this 2 is not a positive 2, it is a -2. And when I multiply this -2 by the -2 in the package, -2 times -2 is a positive 4. Okay? Remember, when you multiply by a negative, you change the sign. So this is actually something we're going to hit a lot in a couple of days. Watch me now, ready? When you're distributing here, you're kind of distributing by two things. You're distributing the 2, which is doubling all the values, but you're also distributing the negative. And to negate means to make it its opposite. Takes good, makes it bad, takes bad, makes it good. So this was a positive x, so in the distribution of the negative sign, it has to become a -2x. And this was a -2, so distributing the negative sign, that is to say negating. To negate that -2 becomes positive. And then 2 times 2 is 4. Okay, any questions on that?
Right here.
All right, go ahead.
You get -5. Wouldn't it be positive?
It is positive 5.
It's just
X
equal.
equals,
Oh, my bad.
Oh.
okay, yes, 2 es muy malo. Now,
What?
you are very bad. All right, now, next over here. What property is this? Associative property of? Huh? That's the one I would have gotten wrong when I was in your grade. Remember I struggled with that? Of addition, because they're all adding. How do you tell the difference between associative and commutative? That's kind of a combination of both. Commutative switches order. Associative changes what's being grouped. Okay? All right. Okay, so we have to learn our properties. And, you know, the way I teach, and I think it takes a lot of kids some time to get used to it, is rather than spend entire periods doing the same thing, I do a little bit of it and we move on, a little bit and we move on. But we do it multiple days in a row, so that hopefully by the third or fourth day you get it down pat. Okay. Sometimes in life it's not only important to know how to do something, but when to do it. Take, for instance, your approach to your mom and dad. We talked about that. When you want something from mom, you have one way of asking. And when you want something from dad, you have another way of
I
asking.
love asking my kids.
See, if my sons know that if they suck up a little bit, they have a chance of getting something from their mother. Perhaps you have a parent like that.
Yeah.
Do not suck up with me.
I got ice cream.
I would look at them and I would say, man up. Just like a man, tell me what's going on here. Give me the straight scoop. What's that?
Have you lost weight?
Yeah, right, there you go. So I do not like that. Mommy. Don't come up to me and go like, Daddy. Now that might work if I had a daughter. But I have sons. So with sons, it's like, get to the point. All right? Now, with these equations, we have to have the correct strategy. What would be the strategy for number 3?
Ooh. Wait.
Go ahead. I really truly didn't hear that. Yeah, but we would even simpler say same side, same operation. Okay, I'm not even looking for you to be as specific as you were being. The next one, what would we do first? I'm looking for a single word here. Distribute, good, and then it would be same side, same operation. Number 5, what would we do to approach it? Go ahead. Opposite side, opposite operation. Very good. All right, so We just did 3 of these on the quiz, and then we just did 5 of these on the do it. So we've handled 8 equations. The overwhelming majority of you got 100 on the quiz. So I'm not going to actually solve those equations. We know you know how to take the first step. Instead, I want to dedicate some time to this concept of closure. Yeah, this is not an easy concept to begin to get across to you, though it's not a hard concept to understand. Once you get it, you're like, that's it? This is all it is? Okay. There is, let me see what time it is. That says 8:59. What do I have, 5 minutes here?
Yeah.
Okay. There is a big argument in mathematics, a very philosophical argument. And I'm going to ask you what you think in a minute. Are numbers discovered or are numbers invented? Don't say it out loud. Think it through. Are numbers discovered or are numbers invented? Anybody feel they're discovered? Anybody feel they're invented? Okay, I'm a big discover guy. Big discover guy. What it parallels to is this. If you believe numbers were discovered, then you believe there's a creator. Because not only did he or she create life, he or she included within the universe the whole number system to be discovered as we go along. If you believe it was invented, then you believe everything's a matter of random chance. And it just so happens we created these constructs of numbers. Now, whether you believe they were created or discovered, how do we generate more numbers if you invent? Or how do we realize there must be more numbers out there if we believe in discover? And it goes something like this. Here's the natural or counting numbers. And these would be the first numbers that man would ever need. For example, if you're a shepherd and you're out in the field and you're counting your sheep and you want to know if you have enough, you could start with like a rock for every sheep. You don't even have numbers yet. You go, you get a rock for every sheep. Then you realize, well, what happens if I lose a rock? Like, what if you drop them one day, right? This would be a disaster. So now you start coming up with numbers. 1, 2, 3, 4, 5, and so on. So you make all your numbers. And then you come up across a complicated problem and you say that now you go up to some, I don't know, Indian tribe chief or something like that, and you make a deal where you trade your daughter for his sheep. Well, that's how they used to do things back then. It was called a dowry. You never heard of a dowry? So I didn't say it was right. My daughter's certainly worth more than a handful of sheep. But let's say he trades the daughter and he gets back the sheep, and he looks up and he says, "I got 7 sheep, 10 sheep. Me got 17 sheep." Okay, so he could do that, and then one day he comes across the whole idea of subtraction. See, if I take any 2 natural numbers and I add them up, if I say 5 and 5, I get 10. But what if I subtract? What if I do 5 minus 5?
0.
And there is no 0 natural number. So what we would say is this. Ready? We would say that the natural numbers, that's the symbol for it,
Oh.
and the operation of addition is closed. Oh, closed. And we would say that because if I take any 2 natural numbers, any 2 in the world, and I add them up, I get back another natural number. Pick a million and a billion. You add them up, you get another natural number. But is it true that if I take any 2 natural numbers and I subtract, that I also get a natural number? No. See, if I take the natural numbers under subtraction, that is not closed. And what do you think we call it when it's not closed?
Open.
Open. So that means I need to come up with new numbers to make it work. Now, let's see what happens if I'm doing multiplication. Let's say I take integers. Integers are positives and negatives, whole numbers, 0. Let's say I take a number like -5 and I multiply it by -7. What do I get? -5 times -7?
Positive 35.
35. Is that another integer? Yeah. Okay, what if I take 10 and multiply it by -3? What's that? -30. Is that another integer? No, I said 10 times -3.
Oh.
Now, is that another integer? Yeah, but if you divide, it doesn't work. So closed means it works, you got an integer. Open means you do not have an integer. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. What? No, you can't, but I can tell you got an 89.
Oh, okay.
All right? Yeah, I don't.